Hello. This video is for IXL activity 7.R.3. It is titled Write Variable Expressions, and this is for word problems. And the 3-character code that IXL uses for this activity is X-ray Mike Delta. So we start off with our first example here. It says that Spencer has 46 more rubber bands than Luther. Luther has R rubber bands. Choose the expression that shows how many rubber bands Spencer has. So our selections are R plus 46, R minus 46, just R, or 46. So whenever we look at word problems, many times we look for the numbers that are important in it, right? And so we know that the 46 is going to come into play there. And the R, well, the R is a variable, so it represents it's a symbol that represents a value that can change. So we recognize the variable as a possible number as well. And many times we have to think about what are the operations? What is it? Add, subtract, multiply, or divide. So it's going to be one of the 4 of these, obviously. We could plug in a number for R to test it out. Let me see. Spencer has 46 more rubber bands than Luther, and Luther has R rubber bands. What if I just said Luther has 10 rubber bands, right? Choose the expression that shows how many rubber bands Spencer has. So 46 more than Luther. So if Luther has 10, then how many more rubber bands? Choose the expression that shows how many rubber bands Spencer has. Luther has R rubber bands and Spencer has 46 more than him. So that means that Spencer has what? 56, right? So we have 46 and 10. Well, to get to 56, we would have to add those. That would have to be 46 plus 10. Well, but 10 we called R, right? So we get a 46 plus R. Well, we don't see 46 plus R here, but we know that with addition, it's commutative. It means that the order can change places, right? So we know that 46 plus R is the same as R plus 46. And indeed, we see that answer right here. So the correct answer is R plus 46. Now, like I said, math has 4 operations. They are addition, multiplication, subtraction, and division. And that on these here, they all are for certain situations. And so we're going to talk about that. So addition is whenever we want to add together different values. So here I have 3 cookies, here I have 2 cookies, and here I have 4 cookies. Well, if I want to know how many cookies I have together, I'm going to have to use addition. I'm going to have to add these together. Well, 3 plus 2 is 5, plus another 4 is going to be 9. So in this case, I have 9 cookies total. Notice the word total represents addition, or I could say that the sum of the cookies is 9. Sum means to add. And I talked about total, so sum, total, altogether, more than. These are all phrases that correspond with the operation of addition. Now, with multiplication is similar to addition. It's related to it in the concept that we're still adding, but we're adding the same number over and over and over again. So, like here we have 4 packs of Oreos. And each Oreo, you can see here, has 6 cookies in it. They all have 6 in it. So I could do 6 plus 6 plus 6 plus 6. And 6 plus 6 is 12. And these 6's make 12. And altogether I have 24. So I could call this 6 plus 6 plus 6 plus 6 4 times equals 12. Or I could just say that I have 6. And actually, I'm going to go the other way around on that. Let's go ahead and erase that. Because I like to think of this as I have how many groups? 4 groups of means to multiply. I'm going to use a dot so we don't confuse that with addition. And so 4 groups of 6. So 4 groups of 6 means to multiply. The word of equals, in this case, 24. So I have a product of 24. These numbers here, the 2 numbers being multiplied times each other, these are known as factors. And the result of multiplying factors together gives us what is known as the product. So I could say what is the product of 4 and 6 would be 24. I could say, what are factors of 24? Well, two factors of 24 are 4 and 6. But the idea is that multiplication is used for the repetitive addition of the same value. If I'm going to repeat the same number over and over again, shortcut, multiply. So subtraction is all about whenever we're starting with something and we're taking something away. Like minus, the word minus is for subtraction. Take away the difference. So the best illustration I could think of for this was the bank robber guy. And so let's say that this young man here happens to have $50 in his wallet. Chances are the robber's going to take everything away, so that'd be 50 minus 50, right? And what's he left with? It's 0. So we could say, what's the difference between what he had before he got robbed and after he got robbed? So difference is subtraction. We could say minus, right? That's 50 minus 50. We could also say less than. $50 less than what he started with, and what he started with is 50, so 50 less than 50 would be 0. So less than, minus, take away, subtract, all these are words that apply to subtraction. And then finally, division. Division is all about starting with one group or one whole and then dividing it, thus the word division, into equal size groups. So you notice here that in this illustration here that all looks like all eight pieces of this cake are cut into equal sizes. The idea of division is it's equal parts. So whenever we have something that's a whole, we think of it as a whole unit. It could be just one object, like one cake being cut into equal size pieces. Or it could be a whole group, like 30 people. It could be the whole group. So we divide 30 into 2 equal groups. So you get 15 people in each equal group. So division is all about taking a whole and dividing it into equal parts. So in this case, I have, well, I was going to say 1 divided by 8, and we get 1/8, and that gets to be a little confusing whenever we talk about 1 at this point. However, like we said, that if we had a group of 30 people, and we wanted to divide it, and I could say 30 divided by 3. So I want to divide it into 3 groups, how many people are in each group. But another way I could write that is 3 over 30, and that would be 3 divided by 30. And both of these, in this case, would be 10, right? There's going to be 10 people in each group. So the whole is the 30 people. It's being divided into equal groups, 3 groups, and there's 10 people in each group. So addition, adding different numbers together. Multiplication, repetitively adding the same value over and over again. Subtraction, we're starting with something and taking away. In division, we have one group or one whole, and we're dividing it into equal parts. So with that in mind, let's go ahead and continue on. And here, Kira planted T fewer trees. Well, fewer should be subtraction, right? She planted T fewer trees than Destiny. Destiny planted 27. So choose the expression that shows how many trees Kira planted. So Kira here is what we want to know. And Destiny planted 27. So Destiny planted 27. And Kira planted T fewer. So we're starting with 27, and to find out however many fewer is equal to what Kira planted. But we only want an expression. This is an equation because it involves an equal sign. So we're only looking for this part of it here. It's on that side there. So 27 minus T, and there we go. The 27 minus T is the correct answer. On the next one, Wyatt has C pieces of candy. He gives away 10 of the pieces. So we started with something, and then we took away from it. So that's going to be subtraction, right? So gives away represents subtraction. Choose the expression that shows the number of pieces of candy that he has left. So he starts with a certain number of pieces of candy that we'll call C. He gives away or subtracts from it 10. So he should be looking for C minus 10. And indeed, here's C minus 10 right there. The Science Club has M members. So M represents the number of members. The club bought 16 bumper stickers. So this 16 is probably going to be important. To split among its members. Split. So it's dividing it between its members, right? So this is going to be a division problem. We're looking for dividing. Choose the expression that shows how many bumper stickers each member will get. So in this case, let's look for what are we splitting? Well, the total number, the total is 16. So we have 16, and we have to divide that by the number of members. So that would be M. For instance, if we had 16 bumper stickers, we're going to divide it between 8 members. They would each get 2, right? So we're looking for 16 divided by M, and indeed, there's 16 divided by M right there. On the next one, Warren has T trading cards. So this T represents the number of trading cards that Warren has. Logan has 5 more. Looks like plus 5 more, right? We're going to add. More lets us know to add, and that 5 is going to be important as well. 5 more trading cards than Warren. Write an expression that shows how many trading cards Logan has. So Logan has 5 more. 5 more than what? 5 more than Warren. Warren is represented with a T, so we have T plus 5. Now, you're going to have to type this in here, T, and use the plus sign on the keyboard on your computer, and then type in 5 and then hit enter on that. Now, if you put 5 plus T, IXL is still going to give you a correct answer because T plus 5, 5 plus T, same thing because of, that's right, the commutative property. Order doesn't matter with addition. So, there we go. So let's look at our next problem here. Addison has 82 caramels. Then Addison's sister took C of the caramels, so 82 is important. C is going to be in that also because it represents the number of caramels that Addison's sister took. Took, just like the guy that was robbing the other gentleman in my illustration earlier. So that's going to be subtraction. We're taking something away, right? And we're taking away from a starting value. So in this case, 82 is what we started with, number of caramels that Addison has. His sister took C caramels away, so minus C. So our expression is going to be 82 minus C. All right, next one here, Miguel had 16 coins, so that's what we're starting with. He then found P more coins. More is what? Addition, right? And P is going to be a value that we need. It's a variable. It's representing a value. So the 16 and the P is what we need, and we're going to add those together. Well, he has 16 coins. That's what he started with, and then he's going to add to that the number of coins that he found in the drawer, and that number of coins is represented by P. I guess he found pennies, right? P for pennies. And so we could put P plus 16. That'd be the same thing. But if you really wanted to be exact, it's what we started with and then what we added to it. So 16 plus P is what we would enter for our answer. The jazz band has 16 members. To raise money for a tour, each member sold R raffle tickets. Write an expression that shows the number of raffle tickets sold. So each member sells the exact same number of raffle tickets, correct? So R is going to be important. 16 is going to be important. And we want to know the total number. Is it right? Expression shows the number of raffle tickets sold. So let's say you got 16 members and they all sold 5 each, right? So we'd have 5 plus 5 plus 5. Get the idea, right? We are repetitively adding the same number over and over and over again. Looks like I got 2, 4, 6, 7 of them so far, and we just keep going, right? Well, that'd be a long way of doing it. So instead, we could say 16 times R. We don't want to use the, we don't want to go and put 16xr. That looks like 16 times x times r, because we want to get away from using this, the x as a multiplication, so we could use the dot. But remember, we could also use parentheses, and we could say 16r. And we know this is multiplication as well, but since there's no such number as 16r, we wouldn't confuse this, as it would be different than if we had 16 times 4, and we wrote that as 16 times 4. But if we did 164 without the parentheses, it would look like 164. We don't have to worry about that here because the r is not, it does represent a value, but it's a variable. And we realize that this is going to be 16 times R, so all we have to put is 16R. Do not type on your keyboard 16XR. It'll count it as wrong. On the next one here, there are 10 swimmers in the swimming club. The club bought C swimming caps to split among its members. To split. So we're dividing something, right? So we're going to need division. So right expression shows how many swimming caps each swimmer will get. Well, they bought the number of swimming caps is what's being divided. So it's going to be C divided by 10. But we don't want to write it as using the division sign. Notice here it says type an asterisk. Oh, there we go. Gee, I messed up earlier. Notice that on this one here, it says type the asterisk if you want to use a multiplication sign. Oh, so we could have done 16 asterisk R. The asterisk on your keyboard, whenever you get into dealing with like Google Sheets or spreadsheets and so forth, and you want to show multiplication, it's the asterisk sign. So you can use the asterisk sign. So this would work here, but just the 16R. So I digress, so come back to this. But for the multiplication sign and a slash if you want to use division. So we're going to type this in. We could say this is 16 over 10, C to 16. Still got that number in my head. C divided by 10. We could write it as a fraction. That's C divided by 10. We just read it just like we see it there. C, the fraction bar says divide, so C divided by 10. Now, whenever we type that in for this particular activity, though, we're going to write C, hit that slash bar, type in 10. So you're going to want to put C slash 10. Use the slash as a fraction bar. And on spreadsheets, the slash sign represents division. So the science club has M members. The club bought 18 bumper stickers to split among its members. This looks like a familiar one before. Or maybe I've been reviewing. Did I have a bumper sticker one? Hold on. I'm going to go check. Indeed, it was. I'm back. Superpowers of pausing there. It did, but it was the multiple choice one. So I knew it. I'm like, something about club members and bumper stickers. Didn't I just do that? Indeed, I did. But the other one was the multiple choice one. So the science club has M members. It bought 18 bumper stickers to split among its members. So right expression shows how many bumper stickers that each person will get. So it's stickers per member. How many stickers per member? So let's see. If we did 18 divided by M equals, well, yeah, 18, let's say the number's 2. You had two members, and 18 would be 18 divided by 2, and that would be 9. So let's see, does that make sense? So you bought 18 stickers, 2 members, and how many stickers will each member get? So indeed, it is the 18 stickers is what's being divided in equal portions toward the number of members. So in this case, we know that 18 over M, or 18 divided by M, worked. So on our keyboard, we type in 18 divided by M. Kyle bought 11 boxes of granola bars. There are G granola bars in each box. Write an expression that shows how many granola bars Kyle bought. So let's say that there were 6 granola bars, right? So we would have to do 6 plus 6 plus 6. You can kind of see where we're going in here again, right? We're adding the same number over and over again until we did it 11 times. So instead of 6 plus 6 plus 6 plus 6 11 times and keep going, we know that we could instead say that it would be 11 times 6. But we don't actually have 6 here. We need G, right? So be careful if you use an example just to check your math and make sure it's working out okay. Don't type in 11 times 6 there. Remember that we didn't actually have 6. We had G. And we could say 11 and then use the asterisk for it. Type the asterisk sign. And see, now I did 6. G, right? But if you just put in 11G here, you'll be good to go. So those are all of my examples for IXL Activity 7.R.3, and it was write variable expressions, and they are indeed word problems. Remember, the key here is to check and see what is the question asking, or am I adding the same number over and over again, or am I increasing some number by something? Actually, that's multiplication. Am I adding different numbers to each other to get a value? Would be addition. And am I adding the same number over and over again repetitively? Would be multiplication. Am I starting with something and taking something away? That would be subtraction. Or do you have a situation where you have a group or a total number of objects and you're splitting them or dividing them into equal groups? That would indeed be division. So go ahead and take a shot at those activities, and good luck.